Welcome everybody to our next WestGrid Town Hall. This time we're aiming a little more at kind of office hours sorts of things, where Alex Razumov, our visualization coordinator and also our summer school coordinator, will talk a bit more about the new systems and how to actually use them. So we're going to dive in. I'm going to do the usual, talk about the new systems, status, availability, some of the bits and pieces, the legacy systems, and then hand it over to Alex, who will spend half an hour or so on say, using the systems. And then we're open to questions. Note that we've got quite a few WestGrid staff on this call, so we've got sort of all the experts. I think it's a good idea probably to just introduce them right now. You guys, if you're on there, can you put your cameras on, your video on? And got some kind of feedback going on. Who just came on? Can you? Cool. Okay. Thanks. Yeah. If you guys can just say hello when I call your name, because then your image will at least appear. So I see we got Alex. You're there.
Yes, I just had to unmute myself. Yes, I'm here. Hello.
We got Ali Karach, one of our analysts. Ali, you there? Okay. Atta Rudgar, he's there.
Yes, I'm here.
Yep. Another one of our analysts, Camille Martinkowski, is there. Hi, Camille. Yeah, he's also the chair of the scheduling committee, and we'll have some things to say about scheduling. Martin Siegert, you're there.
Hello.
Yep. And Lixin Liu.
Hi.
Yep. Both those guys are on the Cedar team itself at SFU. So it's great to see them. Who else did I miss? Masao. Masao, you there? Yeah, Masao, one of our lead analysts. So we got lots of expertise on the call today. And I see people are continuing to come in as we speak. I think that's about everybody from WestGrid, although I noticed that we've got quite a few Compute Canada folks as well. Okay, now that we got everybody and we've introduced the web stream, you can email questions there, video. If you can all unmute or mute your mics until you're ready to ask questions, and you can unmute. And you can also use the chat menu, and there's a little double balloon there at the bottom of the screen. Yeah, anything else, Erin, before we get going? I think we're good.
One thing for anyone who's watching via video, if you double-click the presentation view on your screen, it'll actually open a new window, which you can resize if anything's hard to see.
Thanks, yeah. Okay, well, next slide. Let's, or next couple of slides there. So I'm Patrick Mann. I'm the Director of Operations for WestGrid. And it's really nice to, at this point, after over a year of town halls and preparation, to note that both the big new machines, Cedar and Graham, are indeed up and running. The Cedar and Graham teams, Martin and Lixin there, have been running the top 500 Linpack benchmarks, and we have appeared in the top 100. As you can see on this slide, some of those benchmarks were actually a bit faster than that, because it was difficult to get the benchmarks running with everything, with all the GPU nodes, and we were aimed or focused very much at trying to get these machines available to all our users as soon as we could. So the guys only spent a short time trying to do all these benchmarks, but it's really nice to see it there. So anyhow, there it is. The machines are up. We're feeling pretty good about them, and we've got quite a few users now already on both Cedar and Graham. The announcements went out for the 30th of June. Next slide. There they are, usual thing. and I don't think there's much more to say about that. Alex has got quite a lot more details, and we'll talk about what each of these machines really looks like, and talk a little bit about how you submit jobs. I will note that the Niagara system, the great large parallel machine system in Toronto, is they're still in the RFP phase, just completing that. So we're really hoping that essentially by this time next year, we'll have another 60 or 70,000 cores available for everybody. Aaron, are we next slide? The slides seem to have disappeared. Did they disappear?
Yeah, someone accidentally shared their screen.
Carol, it looks like. Good. Okay. Next slide then. And again, just the overview slide of the storage that we've got. Project Nearline at both SFU and Waterloo. I will have more to say about things like Nearline. It's not absolutely perfect yet. So we'll have to. So I say I've got some more to say. The object storage, still working on that. I've put down autumn for some availability of that one, but I'm not quite sure. It's going a little slow due to the fact that everybody's working on, or has been working on, Cedar and Graham. Yeah, next slide. Is there? Yeah, so a sort of quick overview here. Yeah, the machines came up on, or at least they came up before June 30th. On June 30th, we sort of went to production and included the RAC 2017 compute priorities. So if you got a RAC 2017 compute allocation, those are in the scheduling configuration on the machines now. I think it's still true that that there's quite a lot of development to do. As we're learning about the machines, getting users on them, and the more users we get, the more diverse usage, the more scale-out testing, and users have been reporting issues as we go along. So we're pretty sure that there are still lots of problems to discuss and lots of changes to make as we ourselves learn a lot more about these machines. The machines actually seem pretty stable right now. I think if they go down, they'll probably go down with some warning when we want to change something or modify something. But you can certainly submit jobs, keep them going for now, and things seem pretty good. I also want that last point just to note that you should still report any problems that you come across to support@computecanada.ca. And it looks like somebody else, Rima Singh, I think you're sharing your screen at the moment. Can you stop sharing your screen? So we can, and now we've got an infinite regression going on. Rima,
I'm going to disconnect her.
okay, yeah. Have we got the slides back, do you think? She's still there. There we are. Yeah. Okay. And on the docs wiki, there's a link there, docs.computecanada.ca. There is a known issues page. I'm going to summarize a few of them in the next couple of slides. So next slide. So I'll go through some of these. These are things that I think I know about. They're changing daily. So sometimes when I say there's a known issue, one of the team suddenly pipes up and says, oh yeah, we solved that half an hour ago. So this is good, but I'll go through them. And if any of the team wants to amplify, please break in. So the first one is Nearline. And remember that Nearline is the tape storage, the tape backup storage for the systems. The tape drives and the tape systems are in. The idea with Nearline was that users could put a data file in a Nearline cache, and then that file would be automatically moved to tape. Users could then request a restore from tape if they needed that particular file. So that was sort of a very basic system, and we've been looking at various approaches to a full hierarchical storage management system. However, at the moment, none of that's actually operating yet. We do have tape. The project space is backed up onto tape. But if you got a Nearline allocation, a RAC 2017 allocation of Nearline space, at the moment you can't use it because we don't have that, that automated approach to moving data away from the cache onto tape. What you're going to hear me say an awful lot through this talk, if you need that Nearline allocation, and we've had a few folks who have already had their allocations and need to use it, and we've had to find some alternatives for them. But if you do, give us a call at support@computecanada.ca. The project space, that is, remember, the very large space. It is attached to each of the clusters, Cedar and Graham. It's not scratch space. It's more lower performance, large capacity storage. At the moment, both Graham and Cedar give each user a directory in project/project, and you can go and use that. However, that doesn't really follow our storage allocation approach. Storage allocations are given to the accounting groups, to the PIs, and the PIs have the teams working with them. So we'd prefer to have a project allocation, a project space configuration, which uses the groups, not individual users. And that way we could keep track of your quotas and the total usage for each of the allocations. That's not there yet. So working on that, and in fact there's an awful lot of discussion lately about exactly what that might look like. It's hard to figure out precisely how we would aggregate individual users into the total RAC allocation. So the summary of that is that point 3 there, that the RAC 2017 storage quotas are not implemented yet. Because we haven't got the configuration going. So that's a bit of an issue. We have again had folks who have asked us if they can have their RAC 2017 storage allocations, and yes, we have worked into that manually, so you can, again, if you need them, ask us and we'll do something about it. I think everybody's got, if I remember, a terabyte as the default on project space, so at least you've got some significant amount. Yeah. Right, moving on then. Jobs themselves, there's not too much to say here. Both Cedar and Graham are running a full production Slurm, and Slurm is the job scheduler system. That is different from the Moab and Torque systems that we've been using on WestGrid systems up till now. Slurm has the great advantage of being an open source free version, but it does pretty much everything, so we were happy to move to Slurm. Graham was running a prototype until late last week, so but at the moment both Cedar and Graham are running a full Slurm system, and that's the system within which we've put the RAC 2017 priorities. Email job notifications, I think the last I heard they're working on Cedar but still not working on Graham. So those are when you submit a job and you want to know via email when the job is finished, Cedar will do that, but Graham won't.
I think Graham does it now.
Sorry, Camille, is that you?
Yes, I believe Graham does it as well now.
Okay, I may be out of date. Maybe that that works. The Slurm syntax is different, and we've had quite a few tickets about those. So again, feel free to ask. Yep, I think we're hearing somebody there. Okay. And I'll go to the new slide. The next slide about. Is there a question? No questions. Okay. Yeah, let's go to the next slide about these unused nodes. Can we go to the next slide, Aaron? Yep. No problem. Yeah. Okay. This was late yesterday afternoon. Camille asked me to add this slide. I'll just do it very quickly, but Camille will know all the details. It seems that the scheduling algorithm is designed around using whole nodes preferentially over a whole bunch of cores. This, of course, is much more efficient to use whole nodes just because of things like the communications, where you don't have to use cores that are on different nodes in the system. The Slurm system partitions the cluster itself into partitions, and I think you can see in the diagram that the whole node partition includes the core partition. It's a subset. The core partition is a subset, but it's smaller. So a rule of thumb here is that if you want to use the whole system, you really should be working with whole nodes, not just asking for a whole bunch of cores. And Camille has noted to me that a chunk, 20 or 30% something of the machines are unused at the moment because the nodes are sitting there, but everybody's submitting by core. So that's kind of nice, or an interesting point that we have to get used to how the scheduler works. So it's a really good idea if you schedule whole nodes wherever possible. Similarly for runtimes, there are various runtimes, but a smaller part of the cluster is used for very long runs. Essentially, again, from the point of view of scheduling, a whole bunch of small jobs are much easier for a whole bunch of short jobs are much easier for the scheduler to fit in, rather than having to take one very large job and just letting it run forever. So again, it's better if you can run short jobs, and those will be scheduled faster. The scheduler has a lot more freedom when it can say, oh, I've got 10 nodes available and they won't be used for another 5 hours. Let's just run them, run your shorter jobs on those nodes. So again, really nice to request short run times, and as you can see, there's a 3-hour partition is the shortest one. So really good if you can get your jobs down under 3 hours. Many people can't do that. Okay, the system is set up to schedule the rest of them, but it's certainly much easier to you'll have shorter queue times if you can get it under 3 hours. Yeah, so whole nodes and short run times, and right now that might mean that you get considerably more resources on these machines. I will note that scheduling is a real art. The scheduling team has to look at usage and the way people are using the machines, what the differences are between the jobs, and therefore we can expect changes in the scheduling configuration as we go along, and the scheduling teams learn more and more and can more efficiently use resources. So this may change in the future. I think it'll still. I think aiming for whole nodes will still be the way to go, but we'll be changing lots of it as we learn more and more. Camille, do you want anything else you want to add there? I think I've covered what you told me last night, but you know all the details.
Yes. So especially this diagram here on the left, what it says is that if you have a 3-hour job or less, you could run anywhere on the cluster. But you know, a 72-hour job can only run on a section of the cluster, and the smallest section is the something between 168 hours and 672 hours. So right now, for the short whole node jobs, there's about 200 nodes that are sitting empty on Cedar, 206 actually at this minute. So if you have a 3 or 12-hour, 24-hour job that requires a whole node on Cedar, you can submit that job and it will run immediately, because we haven't communicated this to everybody before, and you guys are the first users that are getting this information across Canada, and this is also true of Graham. So if you guys run shorter jobs that are whole nodes, there's resources available right this minute. And in the future, this will also happen. So you can, if you submit smaller jobs that are shorter, you will be able to run on more of the system. And this is because longer jobs and jobs that require submit stuff by core fragment the system and make it more difficult for other people to run. So we have to reserve part of the cluster for jobs that are shorter and more parallel.
Thanks, Camille. Yeah, so Camille knows the details. So good stuff. There are resources going unused at the moment. Have a go at them. Yeah, next one is the accounting. And there have been, again, some issues around this. When you submit a job using the S-batch, the Slurm batch command, you'll get probably the output that's on the right-hand side, where in the light brown color, and it'll tell you that there's no account. So Slurm needs to know which account you're going to use if you've got multiple allocations. So anybody with a rack, almost by has multiple allocations because they've also got a default. Everybody's got a default, and if you got a rack, well, now you got two, and Slurm needs to know. The easiest way is just to do S-batch, look at what it tells you, choose the name of the account that you want, and stick it in by using the -- account configuration for either S-batch. You can put that in your job script or in the environment if you want. So that's nice. So you can set it up once and then have it be used from then on. I just noticed that the naming convention is not exactly the same as your group names in the compute counter database in CCDB. So I know that there are three prefixes: def, RRG, or RPP. So def for default, RRG for our standard annual rack allocations, and RPP for the research platforms and portals. Yeah, so keep an eye on that. Kind of handy to get that organized once. Yeah, next slide. I just wrote a few bits and pieces here. These are ones that are sort of coming up with me mostly, and I see some tickets and things. So CVMFS and system libraries. Almost everything is in CVMFS. That's a shared between both Graham and Cedar. So Graham and Cedar look as identical as possible. But I've seen some issues, conflicts between using CVMFS and system stuff. So if you have your favorite software and it just won't compile or won't build, then yeah, give us a call. I noticed that Slurm has something called srun, which is a replacement for MPI run or MPI exec. Should be faster because Slurm knows a little more about where the nodes are and how they're grouping, but I haven't heard any details about that. So feel free to play with srun. And the GPU, or the visualization on the GPUs. Remember, these new machines have lots and lots of GPUs. There are still issues with GPU visualization, GPU rendering, and Alex is our expert on that. And we'll be working a little bit, and we'll get more out on the documentation when that end of things works a bit better. Yeah, next slide. So I want to just remind everybody that the legacy systems are still running. A couple of them are scheduled for defunding in the not-too-distant future. So just to note, Hermes and Nestor, the Victoria machines, they were defunded on June 1st, but the data systems were going to be available until a month after the new systems were in production. So the new systems were June 30th. So Hermes and Nestor front ends to the storage systems will be available until the end of this month. So I'd really encourage you to get if you haven't done so, to get your data from Hermes and Nestor and essentially take it and stick it into project space on Cedar. Breezy and Lattice will go away on August 31st. So we got another month and a bit to go with those ones. The shared storage system is for Parallel, so Parallel is still around and will still be around for the rest of the year and was allocated. So the storage will still be there. And in Edmonton, Hungaby and Jasper are scheduled for defunding on October 1st. Again, the new machines are up there. You've got some time now to start migrating, so you should start really thinking about getting onto the new machines as quick as you can. Next slide. And our usual warning that these legacy systems are becoming harder and harder to keep going. Orson has had a file system issue earlier last week. Some jobs were lost. Hungaby has had 2 quite nasty hardware issues. I should say that Camille, as well as being the head of the scheduling national team, is also the sysadmin in charge of Hungaby and Jasper. So he's been doing a great job of trying to play with the hardware on Hungaby. And just to note, we don't have these guys on vendor support. Generally, we keep the storage on support, but not the nodes. It's way, way, way too expensive to do that. So guys like Camille, when nodes go down, have to start juggling spare hardware, other hardware, cannibalizing, kind of thing. Again, so if you're on Hungaby, I really recommend you starting to move to some of those large memory, the fat nodes on Graham and Cedar. And then about Bugaboo, Martin Siegert is also running the site lead for SFU, where Bugaboo is, and trying to cope with the issues on Bugaboo, as well as getting Cedar up and running. And the problem with Bugaboo right now is that there's essentially no storage left. So if you're on Bugaboo, can you please clean up? We'll be probably sending messages out or looking at individuals to see what we can do. But yeah, Bugaboo really needs to be cleaned out. And same comment again, yeah, if you can move it, it should be moved to project space on the new machines, because Bugaboo will go too. Right, yeah. Nice slide here just on summarizing a lot of the training and the documentation available. So these slides, I think, will be available to you. The docs wiki, the docs.computecanada.ca, is where all the documentation is. Still being written as we come up with things. They're updated, modified, and so that's the place to go. And really, we would like any information. If there are any problems or if you see something that you think is misleading, give us a call. And there are a few detailed things about running jobs, available software, storage, and file management. The Ontario folks have developed a bunch of video series, and I think Alex was actually part of that, is in some of them. So have a go with those short video demos, and they do things like how you run jobs, how you manage jobs, those kinds of things. And we've got a webinar in the middle of July about scheduling. So that's the nuts and bolts of the whole works, is how you can get your jobs to run fast. So I'd really recommend going to that. I think Camille is going to give that one. And next slide. Right. At this point, I'm just going to hand it over to Alex, and he'll get more into the nitty-gritty after that rather quick overview of where we are.
Do you want to add any questions?
Yeah.
At this point? So I have muted quite a few people, so if you're not able to speak, you might want to type or email.
So Phil Austin here. Can you hear me?
Yeah.
So I can log into Grex, but I can't log into Graham. Is there an extra step to actually permit my password on Graham?
Shouldn't be,
but
but
you need to use your Compute Canada account, not WestGrid account.
Yes. Okay. So I've set them up for the same. All right. I'll double check. So if I need to file it, what's the next step if that doesn't work for me? I file a ticket.
Yeah. Send to support@westgrid.ca.
Okay. Thank you.
Yeah.
Please send them to support@computecanada.ca.
Oh, okay.
All right.
Right, Alex.
All right, so if there are no further questions, let me proceed. So thanks, Patrick. I'm going to start with showing this table of specs of Cedar and Graham. So the two classes are very similar by design to each other, and a lot of things I'm going to show today on Cedar, they also apply to Gram. And I want to say that Cedar and Gram, so independently of your geographical location, you can log into Cedar and Gram, and you can use either cluster unless you have a rack allocation on a specific system. Cedar and Gram have both close to 30,000 processes, and most of these processes are sitting on 120 gigabyte base nodes, 120 gigabyte shared memory base nodes. And we also have a fair number of fat or large memory nodes for running codes that require a lot of memory. So one example is bioinformatics. I know there are quite a few bioinformatics codes that require access to large shared memory space, and so these are the nodes where you would want to run these codes. So when you submit a job, you don't have to specify explicitly which type of node you want this job to run on. Depending on how much memory, primarily on how much memory you're asking for, the job will go to the right allocation, to the right type of node. So in addition to regular CPU nodes, we also have GPU nodes, two types with 128 gigabytes and 256 gigabytes of memory. And these come with latest NVIDIA P100 Pascal GPUs. So these are meant for running pretty much any type of job that requires GPUs for general purpose computing. So whether it's molecular dynamics code or something else. And these nodes can also be used for visualization. So when you log in to a cluster, to Cedar, for example, by default, you will find yourself in your home directory that has a 50 gigabyte quota for each user. And all files are in your home are backed up daily, or I should say on a nightly basis. So home is meant primarily for storing your important files, your codes, your setup scripts, and so on. But it's not, as Patrick mentioned, it's not a high-performance file system, in the sense that if your code outputs a lot of data, then you probably want to save this data to the Scratch file system, which is simply designed tuned for high I/O rates and for storing large files with much better performance. So the problem, the caveat with Scratch that you should be aware of is that while it does not have a quota, it has a purge policy. So we know that people will be writing a lot of files to Scratch, and it will be getting full quite quickly. So depending on when that happens, we'll be deleting all the files. And of course, we will not be deleting any files without letting you know first in advance, few days in advance. But in general, all files over than, say, a month or 2 months will be deleted with an advance warning. And so the idea of Scratch is that it's a very high performance, fast file system for short-term Scratch storage. So if you want to save files that, for longer than a few months, then you can copy them either to home or to one of the archival storage systems that Patrick already mentioned. So Project and Nearline. Project is disk storage, Nearline is tape storage. So Project is available to every user. There's a quota, whereas Nearline tape storage is available by request. So if you're submitting a request for rack allocation, then please let us know that you need tape storage, and we'll be happy to provide it to you. And so finally in this table, we have the local storage TMP on each node. So this is an SSD, very fast SSD, a local to each node. That means that when your job is running and you're writing something to a node, then when your job stops, you have to, before it stops, you have to make sure that if these files are important, you actually copy them out to your home directory, Scratch directory, because they will not appear on the login node as usual. So we have a lot of information on these file systems in our wiki, how to check for usage, how to request more usage in our wiki. So please check the wiki pages, and there's a link at the top of this slide. So logging into Cedar and Gram, please use your Compute Canada account, not your WestGrid account. To log in, you will simply use SSH and SSH command or SSH client. So if you're sitting in front of a Unix laptop, either Mac or Linux machine, then SSH is already a command that is available via terminal. You simply say SSH, your username at cedar.computecanon.ca. If you're on Windows, there are quite a few options. We generally recommend Mobile Xterm because it not only gives you the command line, but also the X11 server on your laptop. But there are quite a few other options, things like PuTTY or Cygwin, or even the Bash Windows subsystem for Linux. So quite a few options on Windows. It's just you have to install these clients by hand, so they're not available by default. And as I mentioned, on Cedar and Gram, you have to use your Compute Canada accounts, which is a separate set of accounts different from WestGrid, regular legacy WestGrid accounts. So I highly recommend to set up SSH key pairs for passwordless login to Cedar and Gram, simply because you don't have to type the password every time. And this is especially useful if you're editing remote files, because, for example, in Emacs, or there are quite a few editors for Mac and Linux and Windows that allow you to edit remote files. And if you have a passwordless SSH key setup, then you don't have to type your password every time you save or load a remote file. So GUI connections, X11 forwarding works. We don't recommend to use X11 forwarding because it's slower than VNC clients, remote desktop clients, things like VNC and X2Go. But we don't have VNC and X2Go fully set up yet. We're still playing with the setup. So right now you can actually start VNC remote desktop client as part of your compute job on Cedar and Gram. But it's not yet fully set up, and it's not documented because we're still playing with the environment. And perhaps it's highly likely that we'll provide X2Go on the login node as well. Right now we don't. Cluster software environment at a glance. So all systems run Linux, CentOS 7. That means if you're not familiar with Linux, I highly recommend that you follow some tutorial on basic commands in Linux. And we do teach Linux basics in various webinars and also in software carpentry throughout the year at various institutions. So for example, in September, early September, I'll be teaching software carpentry with half-a-day introduction to Linux at UBC, and just take a look at the events section in our webpage, westgrid.ca, and you'll find these sessions. So programming languages will provide pretty much everything that is standard for HPC environment. So the traditional HPC languages, compiled languages, C, C++, Fortran, we provide all of these in multiple configurations. I'm going to talk about these in more detail in a few minutes. We also provide non-HPC programming languages, things like Python, R, and Java. So these don't perform as well as compiled languages, and you probably are aware of this, so I'm not going to spend any time on this. We're also now trying to configure Chapel. That is a new programming language, open source programming language from Cray, and it will be installed on both Cedar and Gram. Right now, it's not yet available, but it's probably going to be available in a few days. So for CPU parallel development, we provide all the industry standard libraries and compilers, things like MPI, message passing interface, for programming distributed memory, parallel codes, and OpenMP threads for programming shared memory codes. GPU parallel development support, we provide CUDA and OpenCL. As I mentioned, Cedar and Gram have new GPUs that fully support the latest CUDA, and OpenCL is available as well. So for simpler GPU programming, we also have OpenACC that is provided by the PGI compiler, commercial compiler that we have on the systems. So for job scheduler, as Patrick already mentioned, we're using Slurm, open source scheduler and resource manager, and I'm going to show you many examples of how to submit jobs via Slurm. So for software installations, we have, this morning I counted, we have around close to 200 packages installed already centrally on the systems, and these are available via software modules. I'm going to show you in the next slide how to load these. So they're generally installed under CVMFS directory tree, and you have to use the right, to load the module before you can actually use these packages. If you find that something is not available and you want to use it on a cluster, please let us know. There are two options. Either you can install this yourself in your home in one of your directories, and we'll be happy to compile it for you. Or you can simply ask us to install it, and if it's a package that runs in Linux, that can be compiled in Linux, and that is compatible with the HPC environment on our clusters, let us know, and we'll be happy to install it for you. So software modules, as already mentioned, we have close to 200 packages, and to make these packages available, you have to load the appropriate modules. So the command for that is module load followed by the package name. And to list all packages that are available, you can simply say module avail, optionally followed by a pattern or package name. Module spider will give you a little bit more information. Module unload, module show to show more detailed information on what the module does exactly. So all prerequisites and all module dependencies are loaded automatically. I'm going to show you in a second how, a few examples. And finally, what I want to say here is that modules, so if your job uses a specific package, a specific software, the correct module, the right module has to be loaded before you submit your job. So let me now switch to the terminal. This is the terminal on my laptop, and I'm going to log into Cedar. So I simply run the command SSH, my username at cedar.computecanada.ca, and hopefully the fonts are big enough so you can actually see them. If not, then you can double-click on the shared window, and it'll expand into a larger window with that you can resize to make the fonts bigger. So right now I'm on Cedar, in my home directory on Cedar, and what I'm going to do, I'm going to simply type module avail. Oops, sorry. Module avail to show all the available modules, and you see there are quite a few of these. So you can actually specify things you're looking for. For example, if you're interested in, let's say, visualization, you can check for the Preview module, module avail Preview, and we'll show that there are two versions of Preview available. One is a GUI version, Qt version. The other one is the off-screen off-screen version for CPU-based rendering without opening any windows. If you want to check for, let's say, all versions of the Intel compiler we have, well, you can simply see module avail Intel, and it will tell you that there are two versions of the Intel compiler. Let's say you're interested in all versions of the GNU compiler. Module avail GCC will tell you also that we have two versions of the GNU compiler, and so on. So the spider command will give you a little bit more information. But the idea is the same, that it will simply list all the modules that are available. So by default, when you log into Cedar, some modules will be loaded. And to check the list of loaded modules, you can simply type module list, and this will show the default modules. So notice that the Intel compiler module, this one is loaded by default. So if you compile codes, the default compiler is the commercial Intel compiler. If you want to switch to GNU compiler, that is very easy to do. You simply say module load GCC and hit enter. And what happened was that the Intel compiler module was unloaded automatically, and then the system loaded the GNU compiler module. And it also unloaded the previously loaded OpenMPI, so MPI Parallel Programming Library module for Intel, and loaded the right OpenMPI module for the GNU compiler. So now if I do module list, again, it will tell me that the GNU compiler GCC 5.4.0 module is loaded now, and we also have the right OpenMPI module for the GNU library. And then to unload a module, I can simply type unload, and then followed by the module name. For example, I can unload the OpenMPI module, and here we go. And then check the loaded modules again. Now I have 5 modules instead of the 6 loaded. So let me go to the next slide. A file transfer, just want to mention these very briefly. There are several options. You have to transfer files between different file systems, well, between different clusters in Compute Canada and WestGrid and your local laptop or desktop. You can use command line tools, things like cqcopy or async that are available on Mac, Linux, and also there are clients for Windows. And so for these, you can simply say cqcopy source, the location of the source file, the location of the target directory where you're putting this file, and cqcopy will simply copy securely with SSH encryption the file from one location to another. In this case, the first example from a laptop to the Cedar cluster, and in the second example from Cedar to your local machine. And also you can use async command that will, so the idea of async is that instead of supplying the exact file name that you want to copy, it will simply sync the two directories, for example, a local directory and a remote directory. So the problem with async, its performance is not particularly great, especially when you have a lot of files in a directory. And especially if you're trying to transfer very large files, we highly recommend to use the Globus file transfer tool. So there's a web portal at globus.computecanada.ca. And if you go there, you can log in with your Compute Canada credentials. And then you'll need to open 2 endpoints. So basically, there'll be a panel with a file system on the left and a panel on the right. And you can simply click on the file or files that you want to copy from one location to another. And you click on the copy or move button or something like that, and it will start transfer. And then you can even log out. You can close your browser, and it will all happen in the background. And then once the transfer is finished, it will by default it will send you an email that a transfer is done. And it's very, very reliable, very safe, and it's very convenient because you don't have to stay logged into the system to actually transfer files. And performance-wise, it's also really great. So it's much faster than regular cqcopy or async. But there are a few caveats. So sometimes you will get into problems with eduroam or your ISP, but that's a standalone issue. So install compilers, we have three families of compilers: the Intel commercial compiler, the GNU compiler, and the PGI compiler installed on the systems. So these can be used for compiling serial codes, MPI codes, and OpenMP codes. So to compile, let's say, a regular serial code, C code, with the Intel compiler, all you have to do is simply say ICC, followed by the file name of your source code, and it will create an executable that you can run or submit to the job scheduler. If you want to compile an MPI code, whether it's a C, C++, or Fortran code, then you'll need to use one of the MPI wrappers, MPI scripts, according to the options in this table. And then if you want to compile an OpenMP code, you will need to pass the right flag, whether it's the -Q OpenMP for the Intel compiler, -F OpenMP for the GNU compiler, or -MP for the PGI compiler, to the corresponding command line. So if you want to see what the MPI scripts do exactly underline, you can simply type MPI, let's say MPI-CC -show, and it will tell you exactly which command it uses and which flags it uses to link to the right libraries on the system. Here's the slide on the scheduler. Let me actually go back to the shell. I will log out, and then I will log in again to Cedar. And here are my default modules. So the Intel module is again loaded by default. I will go into the directory that has some sample files. So I will, here's a bunch of C files that I have. I'm going to compile a serial C code, and I'm going to submit it to the scheduler. So to compile the C code, right now I have the Intel compiler loaded. I simply say ICC followed by the name of the source code. So in this case, it's a simple serial C code to compile Pi via a large series, and then I'll say that. And actually, it's a very good idea to supply the name of the executable. So I'm going to call it serial. The executable is called serial, and then serial was just created right now. I can check for it. It's sitting right here. And then I'm going to use the following job script to submit the job. So this is also mirrored in the slide. If you look in the slide, what I'm doing here, I'm basically saying that here's the job script called job_serial.sh. And it's basically a bash script that contains the following flags to the Slurm scheduler. So everything that starts with the number sign as batch, followed by a specific flag, is an option to the scheduler. And you can pass these options either by the job submission script, like in this case, or you can also supply them in the command line. We prefer that you do that inside the script, simply because if you submit a lot of jobs, then you will have a track record of which options you used exactly. Whereas if you supply these in the command line, then these exact options will be lost in history very quickly. So in this case, I'm submitting a serial job, and I'm asking for 5 minutes only. So the format is hours, column, minutes, column, seconds, 5 minutes, and optional can supply the job name, but you don't really have to do it. And I'm asking for 100 megabytes memory per core, and it's a serial job, so there's a single core. And then in my case, because I have several accounts in Compute Canada, I have to supply the exact account, the exact allocation under which I want to submit this job. And then so these are what I highlighted are all the flags I need to submit a serial job. And then the last line in my script is the name of the program that I'm going to run. So what I'm going to do now, I can simply say as batch job _serial.sh. I'm going to hit enter, and it will submit the job. So it says submitted batch job number, and then I can simply check for the running job. So I'll say SQ -U followed by my username, and it says the job is running. So status R means running. So let me check again. So it's still running. It was submitted just a few seconds ago, but it's a quick job. So it's just finished running. It took about 10 seconds or so. And if I do ls in my current directory, there is a file called slurm-jobid.out, and it actually contains all the terminal output that my job produced. So in this case, it printed simply pi and the error. So this is how you submit serial jobs, right? You just need to specify a few options and then say as batch, optionally supply some flags, followed by the job submission script, and then the job should run hopefully soon. So to check for running jobs or pending jobs, jobs that are in the queue but that have not started yet, you simply say SQ minus U followed by your username. And then for a completed job, if you want to check how much resources it used, for example, one of the important things you want to know is how much memory it used. You can simply say SACCT, that stands for Slurm account minus G job ID, dash format, followed by any number of fields that you want to show. In this case, job ID, the maximum resident size, so the memory footprint of your job, and the elapsed time. And it will tell you, for a completed job, it will print out that information. So this is how you submit serial jobs. The next slide is submitting array jobs. Here the idea is the same, that you submit a job that was compiled, the serial job that doesn't use any parallelism. But you can submit a bunch of jobs as a single, in a single step. And the idea here is that instead of submitting, let's say, 30 or 100 or how many serial jobs, you simply submit a bunch of them to the scheduler, and it will be much easier for the scheduler to find an allocation for your jobs. For example, it might use a whole node allocation or something like that. And then these jobs are exactly the same. They will use exactly the same executable, but they might differ in the list of parameters that they take in by an input file. So in this example, for example, I have the executable that is called my program, and then I pass an input file name to it. So there are 30 instances. There's 30 executables that are going to be run as part of this job, and they will respectively take the input file names called input1.dat, input2.dat, and so on. And this is done by the Slurm environment variable called Slurm array task ID that will simply take the rank of the task that is currently running as part of a single job. And all of this is spelled out in more detail in our wiki pages. So if you have any questions, feel free to ask them me at the end of this webinar, or send us an email, or simply go to our documentation wiki pages. So to submit an OpenMP job, you will do something very similar, except that now you have to obviously compile an OpenMP job. And also you'll need to specify how many processes you want to this job to run on. So in this case, I'm asking for 4 cores. So it's a single task OpenMP job, but there are 4 cores that will be used as part of this in this run. I'm also asking for, in a slightly different format, in this case it's days, hours, and minutes. Again, I'm asking for 5 minutes, 100 megabytes for the whole job, not per core, but for the whole job. I specify my account under which I want to run this job, and then I need to specify this variable OpenMP num threads that is going to be used by the job at runtime to find out exactly how many threads it needs to launch during execution. So this variable is passed to the actual executable OpenMP. So let me run the demo. I'll have the code here. It's called shared pi. Again, the same algorithm, but now it's an OpenMP job. And to compile it, I'll simply say, so for let me go back to the slide. For the Intel compiler, it's minus Q OpenMP. So I'll simply say ICC minus Q OpenMP shared pi, followed by the name of the executable that I'm going to call shared, or I guess I should call it OpenMP because that's what I have in my job submission script. It compiles the code. Now I have the OpenMP executable, and then I'm going to submit the job using the script called job openmp.sh, and this is exactly the same script I showed on my slide. And all I'm going to do is say as batch followed by the script name, and then it will run the job. So let me check for the queue. So I think the job already finished running. So let me check ls. There should be 2 files. Yep, now there are 2 files. So the serial run, and then the output of the serial run, and the output of the latest run. Let's see. Yeah, that's the latest run, the OpenMP run, and this is what the OpenMP run produced. So remember, there's a line echo running on this number of cores, and that's what it says, running on 4 cores, and then pi and the area in computing pi. So next slide is submitting MPI jobs. So the idea is the same. You have to compile, in this case, an MPI job. So I have the script, the code, again, C code that was parallelized using the MPI library distributed pi.c. I simply compiled with MPI-cc distributed pi.c minus O MPI, and then I submit with the script. Now the script asks for more than one MPI process. So I'm saying --tasks equal to 4. So I'm asking for 4 cores for 4 MPI tasks, and then each MPI task will run on a single core. And then I'm also asking for 5 minutes, and then 100 megabytes of memory per task per core. And then I can run it using the srun command. So srun command will simply take the executable, in this case MPI, and it will run it. It will basically launch the write parallel environment at runtime, and it will run your job. So let me do this. I will simply say MPI-cc distributed pi.c -o MPI. That's the name of the executable, and then it was created. Here we go. And then I'll say sbatch job MPI.sh, and then it was submitted. It gave me the job ID number, so let me do sq. Oops, sorry. sq-u Razumov, and it looks like it ran already. So let me do Slurm and check for the output. So you see that it didn't take any time to run at all. So it ran a 4-core job, 4 processor job, and then it says process given rank 0 to 3 out of 4 started, and then it computed pi in parallel using MPI library. So let me show you how you can actually use the scct command. So basically, you'll need to say that for a completed job, you'll say scct minus g, then let's take the latest MPI run, that's the job ID. And I'm curious about the memory it used. So I'm running this command, and here what it says. So there are several fields here, and actually I'm not sure which field is the, let's see, which field is going to be the right one. So in this case, sorry, I'm not actually 100% sure. But the idea is that it will show, so in max SS, it will show you the maximum resident memory for the tasks that use the most memory. So one caveat with this is that Slurm pulls memory at distinct points in time, so that sometimes if you have a memory spike that caused your job to be killed, Slurm might not have pulled the job at the right time and might have missed that spike in memory usage. And in this case, it will not report the memory usage correctly. So you have to be aware of this. Submitting GPU jobs, the idea is the same. You basically ask for how many nodes you want to use, how much memory you want to use per node. And in this case, you need to supply a specific GPU requirement. So I'm saying that use 1 GPU per node, ask for 3 nodes. And then your job will run on not on the CPU partition, but one of the GPU nodes on the cluster. And depending on whether these nodes are busy or not, so depending on how many GPU jobs are currently running, your jobs will start, and maybe you'll have to wait some time, and then it will be run on one of the GPU nodes. So interactive job, a very important slide. You have an option to submit an interactive job. That means that you'll get, so once the job starts running, you'll get immediately a job prompt, a bash shell prompt as part of your job, and there you can run interactive commands, and these commands will be part of your job. So why is this useful? Well, perhaps you want to debug or test your code, and you want to run multiple instances. In that case, you do submit a single job, and then you run multiple instances as part of the job. Alternatively, maybe you're doing visualization, and you want to run some sort of a server, let's say VNC server, or a Paraview server as part of your job, and then you run the corresponding client, let's say Paraview client or VNC client on your laptop, and you can connect the two via SSH port forwarding, and then you can actually do interactive GUI work as part of a scheduled job on a compute node. So for visualization, we actually have, yesterday I added some documentation linked here to the wiki on how to do interactive Paraview client server visualization on Cedar and Gram as part of the interactive job on a CPU node. So as Patrick mentioned, GPU-based rendering is still buggy. It doesn't work yet. but we're working to bring it to you. But CPU-based rendering works. You can do it in serial, you can do it in parallel, and it works very nicely, actually. So Slurm script flags and environment variables. I'm already mentioned this, so I'm gonna, because we're running out of time, I'm gonna advance the slides. So this is Slurm jobs in memory. This is something that I mentioned briefly already. So your job, if you don't ask for enough memory, and your job uses more than the limit you specify, your job will be killed. So you have to be careful to specify the right amount of memory. And obviously, if you specify too much, then your job will end up waiting a long time in the queue because you ask for too much resources. And then when it runs, it will not use all the memory. So some part of the resources will be wasted. So it's a very good idea to know very well how much memory your job is using. And it's actually quite tricky because if you don't know the internal structure of the code, then, and you don't know what the data structures are being allocated by your code, then it's actually very tricky to find out exactly how much memory you'll need. So the best option you have is to use the SACCT command that I already mentioned to probe the memory usage of a recently completed job. And then when you schedule the next job, give yourself a little bit of a cushion, maybe 15 or 20% on top of your estimate, and then the job should run safely. So, but be aware, please, of what I mentioned already, the discrete time polling nature of slope memory estimation. It might not be always accurate because it runs it maybe once a minute, or maybe a few times a minute, and it doesn't, for sudden spikes in memory usage, it just will not be able to capture these. Getting information about your job, I already mentioned some of these commands, and because we're running out of time, I will not spend much time on this. So best practices in computing. So these are some things that we try to stress often, and some of these things Patrick mentioned already earlier today. So production runs, please make sure that anything CPU intensive, you don't run on the login node. It has to, these jobs have, well, these calculations have to submit it to the scheduler and to run on as part of a submitted job. Please only request the resources, runtime, and memory that you need. Don't ask for, let's say, 7 days or a day if you only run an hour-long job, simply because your job will end up waiting for a long time and then resources will be wasted. For faster turnaround, so this is something that Patrick and Camille mentioned already. It's a good idea to ask for whole nodes just because, well, simply because of the partition setup in Slurm on the clusters, and for short run times, and then your job will run faster. Don't run unoptimized codes. So when you compile the code, there are flags, compilation flags -02, -03, and these are used automatically with the MPI scripts. But if you say GCC, YCC, use the compiler commands directly, then it's a good idea to also specify, let's say, -02 for compilation optimization. It will take a little bit longer for the job, for your code to compile, but the job on average will run several times faster. Be smart in the choice of programming languages. So please know that things like Python and R can actually be very, very slow in native loops and native arithmetic. So it's a good idea to use a compile language if you can. File systems are not, so parallel file systems are not optimized for storing a large number of files. So unlike on a laptop, you can create, on your laptop, you can create a directory with, let's say, 100,000 files, do less, and will pretty much list all the files in the directory. On a parallel file system, there will be lag because these systems, parallel file systems, have been optimized for storing a small number of large files for high I/O bandwidth, but not for storing a large number of small files. So if your code, for some reason, outputs a large number of files, then either modify your code to simply output fewer files, or use usual Unix archival commands, things like tar and DAR, disk archival tool, which is actually not known to many people, but which is incredibly useful and is an open source replacement for tar. But it also comes with built-in indexing, so searching and extracting files with tar is much, much easier than with tar. So don't store large files as ASCII tags, simply because binary storage is much more efficient. Use scientific data libraries, such things like netcdf and HDF5, simply because they will give you portability, compression, binary storage, and much better I/O efficiency. So we have a lot of documentation, and as we speak, we keep adding a lot of documentation to the wiki pages. So wiki pages are editable by users as well. So if you have some useful tips or hints please don't be shy. You can add these to the wiki pages as well. If you have any questions, let us know. So the main email address is support@computecanada.ca. There are also multiple addresses for specific comments, things like questions on Globus, for example. You can send an email to globus@computecanada.ca. But if you're not sure which exact email address to use, simply send an email to support@computecanada.ca, and your question will go to the right queue. Also, please, in your email, please try to give as much information as possible, simply because the more information we'll have from the beginning, things like error messages, which cluster you're using, exact location of your job, which job script you use, and so on. So the more information we have from the beginning, the faster we'll be able to help you. And also, please get to know your local support. We have WestGrid staff in most WestGrid partner institutions. So these staff will be happy to help you, especially if you're a novice user, if you're just getting started with Compute Canada systems and you're not sure how to proceed. They will be happy to meet with you in person and answer all your questions. So, final slide before questions. We provide a lot of training, and we try to do face-to-face training as well. So starting this summer, we try to run in the future, we'll try to run 2 summer schools per year. So actually, a few weeks ago, we had a very successful summer school with 160 participants at UBC. And then in 2 weeks, we're going to do another one at the University of Saskatchewan. So right now we have about 50 people registered, and if you're close to USask, if you are in Saskatchewan or perhaps in Manitoba, Alberta, feel free to register and attend this school. So it will run for 4 days, and there will be quite a few sessions. So the first 2 days will have plenary sessions. Introduction, first day is full day introduction to high performance computing, basically all the stuff I showed today and lots of hands-on exercises. And then second day we'll do a full day course on Chapel, also plenary session. So parallel programming, shared memory, and distributed memory programming in Chapel. Really, really easy to learn, really high language, and much easier to learn than, for example, OpenMP and an MPI. And several domain specific sessions, so material science and bioinformatics, and then several sessions in the last 2 days. We'll have 2 parallel streams and several sessions on GPU programming, Globus, and scientific visualization, and then computing with PETSI. We'll have a break in August, so we don't have, I don't think we'll have any webinar scheduled for August, but starting in September, we'll resume with introductory and more advanced webinars, and please keep an eye on the WestGrid events page for these. So I will end here. I went quite a lot over time, I see. If you have any questions, please let us know. Please ask right now or send us an email. If you are in video, you can unmute yourself and ask the question via audio, or use the chat, video chat in the hover. If you hover the mouse pointer over the video window, the second button in the toolbar will open the chat window. So questions?
Yeah, thanks, Alex. I guess a few of us will just stay around if there are any questions. But otherwise, I see we've had some questions coming in during the time, but otherwise I think we're about done. Okay, well, thanks for coming, everybody. And we'll probably be here for a couple of minutes now.
Hi. Hello?
Yes.
Yep.
Hi. So the allocations are not implemented yet on Cedar, I guess?
The compute allocations are implemented, but not the storage.
Okay.
Yeah.
So if I have allocation, does that on the CPU side, does that give me access to the GPUs, or there are separate allocations? So I can answer that. So if you have a CPU allocation, you cannot spend your CPU allocation in terms of GPUs, because the GPUs were allocated to other allocations, right? But everybody has a default allocation, and you could use your default allocation to run GPUs just like any other user can. But you can't spend your CPU allocation on GPUs, right? Okay. Because otherwise we could have, all the CPU users deciding to use the GPUs, and then there wouldn't be enough GPUs to go around to the people that were actually allocated the GPUs.
Okay. So the memory is the smallest one is 128 gigabyte per node, I think.
Yes.
Okay.
But those nodes have 32 cores, so that's 4 gigabytes per core.
Okay. So I was not running conservatively because I thought the allocations are not implemented yet. On the website, it's still the status that it's available for opportunistic use. For Cedar.
Where is that? Yeah.
I guess on the wiki page for Cedar.
Oh, okay. Yep, we got to update that. Thanks.
Okay. So that means I lost part of my allocation for the last week or so.
So allocations don't work the way you're implying from your question. So the way allocations work is you get, if you use more than your allocation in a certain window, then your priority goes down.
Okay.
And if you use less than your allocation in that window, your priority goes up. But that's a window of time, so your usage now will not affect your usage 6 months from now, right?
Okay. I mean, let's say my allocation is 100-year course.
Yes.
So after I finish those 100-year cores, my allocation will go down. My priority will go down, or
no. So if you use 200 cores over the last 2 weeks or last month,
yeah.
right? Then your priority will be down right now. But
yeah.
3 months from now, your priority will be the same because the window has moved.
Okay. Right.
So the allocation basically means that you have access. You will, if you keep jobs in the queue all the time, you will actually get your allocation. But it cannot mean that, you know, if you wait until the end of the year and ask, you have allocation of 1,000 cores, wait until the end of the year and then try to run, 12,000 cores for the last month, right? Because if everybody did that, that wouldn't work. We couldn't guarantee any of those resources.
Okay. So just to make sure, if I said I have 100 core years allocation, and I ran, let's say, 1,000 for a month, which is covering 100 core years.
Mm-hmm.
After a couple of months, my priority will be back the same.
Yes.
Okay, perfect. Thank you. Another question is, you said there is 240 cores or nodes available for 24 hours jobs.
Well, I mean, this changes minute by minute, right?
Yeah,
They have changed.
Yeah.
I think, actually, there's only 142 nodes available for 3-hour or longer jobs.
Oh, okay.
And I think that also includes GPUs. So basically, people are already jumping onto those nodes while we speak.
Okay. Another question. Too many questions. Sorry. I'm covering them. Is there a simple way to see summary for the whole system? If I'm supposed to access that at the first place.
Which type of summary?
Like how many nodes available on what part of the cluster? Like, for example, knowing how many nodes are available for the 24 hours jobs right now.
We have some data about this, but just because a node is available doesn't mean that it's available to you to run immediately. So there's also the possibility that somebody's trying to run a really large job.
Yeah.
So if somebody wants to run an 8,000 core job and they have a high priority, then those nodes may be empty because we're waiting for more nodes to become available for that big job to run.
Okay.
So just because there's empty nodes doesn't necessarily mean that they're not being used. They just could be reserved for a bigger job that's starting. So it's really difficult to give you really accurate number.
Okay.
We could give like a semi-accurate number of how many nodes aren't being used right now, but we don't know why they're not being used.
Okay.
Or we can find out. We can find that out, but it's not very simple, and it requires a lot of digging from us.
Okay. Or okay. Yeah. Thank you very much.
I have a question. Do you hear me?
Yes.
I'm completely new to this, and I was hoping also my grad students would attend, but I don't see the names, so I'm going to ask the question. I'm from SFU, and we have large jobs that we cannot really complete on the latest GPU that we bought. So we are thinking about doing some machine learning and analysis of large data from the internet using your resources. But I'm completely new to it. I'm a Unix user, but I never used the WestGrid. So is there any local help and hand-holding that we can get in order to get started?
Yes, absolutely. We have quite a lot of stuff at
You
SFU.
have to speak slowly for me, dear.
Sorry.
Because you speak too fast.
We have quite a lot of stuff at SFU. So Martin Cedar, who is here on the call, he has the WestGrid analyst team at SFU. And you can talk to Martin. You can talk to Ara and a few others, and myself as well. But I work more on the visualization side. But yes, for sure. So send an email either to me or to Martin or support@computecanada.ca, and we'll be happy to set up an appointment.
Great. And do I have those email addresses?
I can email you. I'll find your email from the RSVP.
That would be great.
Send you that.
So that we can get started, because I have been thinking about it for a long time now, and it's really confusing for people who have not used it before. So let's hope for the best. And I'll get my 2 students to come and join. So if you send me email, we can maybe even meet this week.
Absolutely.
All right, great. Thank you very much. Thanks.
Yeah, there's one other comment I'd like to add, is that there's both Compute Canada and WestGrid training sessions of different types that are available as well.
Okay. Thank you.
Just to confirm, did you RSVP'd for this workshop?
Yes, I registered maybe 8 minutes later.
Okay.
Then I got stuck. I use Mozilla, and it cannot use Mozilla. It has to use Chrome, and then I finally downloaded this video business, and so it was a bit complicated. I maybe missed only 10 minutes at the beginning.
Okay, I'll find your email then.
All right. My email is ljilja@cs.sfu.ca.
Okay.
Can you find me?
I'll find you.
Thanks. So maybe we can meet this week. It would be great, because I really need to get started. And it's this big data and machine learning and Python. And I noticed you have Python, so that's a plus. Great, thanks.
Camille, I see there's one more question on the chat. Is there a wiki page on the allocation and the priority system? I don't think we've got anything major written about that, but you've got a bunch of notes and a presentation.
Yes.
So,
yeah. I'm creating a presentation that will go really into depth on how to use Slurm from the top to the bottom and include both the allocation and priority system. But that's going to be in August, September timeframe.
Yeah.
And that presentation will take probably something like 9 hours over the 3 sessions. And it will go from the top to the bottom of, from the very beginning on how to run and use a scheduler, to how to submit jobs, use job arrays, how to see what's going on in the system, and understand and use everything at the high level as well.
Okay, thanks. Yeah. And then there's a question from the email. How often is scratch space on Cedar purged? Martin, Lixon?
We don't know yet. It varies between immediately after a job finishes till probably several weeks. We need to get a handle on that. So initially we might be somewhat liberal there, but if the space, if we run out of space in Scratch, it will be much more frequent. So in principle, if you're using Scratch, you should clean up almost instantly.
Thanks, Martin. Yeah, and there was another question: why is the available space on TempDir much smaller than it was on Hermes Nestor, for example? I don't think I've noticed that. But,
so first of all, there was a tiny mistake in Alex's presentation. He said that you should write to /temp on the local nodes. To be absolutely clear, you should never write to /temp. /temp is in memory, and you're running your job out of memory. It's a very bad idea. The local Scratch directory on the node is called /local Scratch, and you should write to that directory. And it's not quite done, but the idea is to set up TempDir such that it points to local Scratch. If you write to /temp, then indeed you only have a tiny amount available. But it's really the reason that you're writing to the wrong directory.
okay, thanks, Martin. Right, any more questions? Nope, looks good. Nothing else coming in? Well, thanks, everybody. And,
Thank you.
Thanks to all the WestGrid folks who joined in and contributed. Thanks, guys.